everyone. How are you today? So hopefully you have the great session this morning. So my name is Tan from Deloitte. I'm very excited today in this testing talk event. I think this is a great event for our testing community. This is the opportunity for us to meet, to share the story, experience that we have. The topic that I want to share with you today is about continuous testing, what it is, why does that matter, and how we can build the, and how we can build the quality in our DevOps pipeline. So before that, can I ask the audience here, is any one of you a developer? And do you have DevOps pipeline with CI testing implement in your organization? Yes, perfect. I want to share our experience with you, and I'm also keen to learn from you. So if you see something here, I'm happy to share with you our experience. But if you do something and you don't see it here, I'm very keen to learn from you. So let's make the conversation happen after this. So the roadmap of today, we are going to have a bit of introduction about continuous testing, because not everyone knows what it is, why does that matter. And then we go to the core principle of continuous testing. In that, we will go through the good practice, what should we do, what we should not do in this area. Then we go to the live demo. So in this live demo, we will show you the example that we have to show the value of continuous testing when building DevOps pipeline. Then we go back to the slide and talk about what we can do next into the CI. So hopefully, whether you are a developer or tester or engineer really, after this session, you gain some practical insight in our experience. Now let's start with the very classic challenging that we usually see in our software life. This is the balance of quality and speed. So we often see this problem, and we wonder what should we focus on, whether we focus too much on quality or speed, especially in this area, right? Today, especially with AI, you can do things a lot faster. And I don't know if you are using AI in your development work, but I use one. I use one to create the application, and I build one API with all the automated script there using Copilot. When I asked AI to create unit tests for me, it's created a whole bunch of unit tests, but then a lot of them fail. A lot of them pass. Then I asked Copilot, let's fit all of the unit tests. Then it's actually sneakily going to fit the application. So instead of fixing the test, actually change the behavior of the application. So it raised an alarm to me that this is so dangerous. So if we don't have the proper mechanism to manage the quality here, we just let AI do that by itself, then we tend to create a problem without the proper review, proper quality gate. So it's so important nowadays. We need to be more focused on quality. But in the other hand, we have the side of the business. Always want to have the product or software to be delivered on time, right? So we don't want to be delayed. So let's go back a little bit, because we need to focus on that to prevent the bug and prevent the technical debt in production. So because they are so expensive. But we also have the demand that we need to deliver fast so that it can serve the business objective. And we don't want testing to be the bottleneck. We don't want it to be slow, right? So how can we solve this problem? The key to this is not either to one of them, but to create the ecosystem. where we can really focus on the quality. Also, we don't slow down the delivery process. So continuous testing could be one of the solutions for this, along with the other. So continuous testing is all about running the automated test. So in your pipeline, so that you can get the immediate feedback. So the key work I want to highlight here is automated test and immediate feedback. We cannot do continuous testing with manual testing, right? And the value of continuous testing is give you the immediate feedback. So the faster the feedback that you give, the better that you can fit the problem, right? You understand that if we are the developer, for example, we develop the software, then we deploy, and then we have the QA team to do testing. And then after a while, someone come back with a list of the defects. So we lose the context of what we were doing. So it potentially too late. So we want to implement that more continuously in our pipeline so that it will pick up much more earlier. So in doing that, it requires discipline, it requires proper process, and first of all, we need to build the principle for that. So here are core principles of the continuous testing that we usually apply. The first one will be automation first mindset. So whatever you can automate with reasonable effort, and you think that it can bring the benefit, so let's automate that. Unit testing, integration testing, smoke testing, regression testing. So automate that. It's not only help with the execution time, because it obviously will be run faster, but also about this scalability. We want to scale this. We want to run that on different environment. We switch the environment. We want to run that with different data set. We switch the data set. So manual testing, we cannot do that, right? Also, it will help us to ensure the consistency of the result. The second principle of that is embedding the quality check early in the stage. So it's quite aligned with the ship lab testing concept, but ship labs is more wider. It starts from the requirement until the operational stage. But this continuous testing starts from the time developers start doing the work. So we start from every single code commit, every build, every deploy. We verify after every step there. So we put the quality control in each of them. And more often, we tend to focus on the functional requirement rather than the other non-functional requirement like performance or security or compliance testing. But keep in mind that users not only want the working software, they want the working with high-performance software, secure software. So those are very important, and we should not be ignoring that. The third principle is on about the feedback action. So as I mentioned earlier, so if we can provide the feedback faster, the fix will be very easy. It's a good practice if we can build the real-time feedback with the dashboard so that after we deploy anything, we push anything, we see the result immediately. And because developers have the right context at the right time, so developer can fix that much more easier rather than waiting for the later stage. The last principle that we usually apply is risk-based testing approach. So we all working on the quality space, right? So we know that we cannot test everything. So we need to pick the right feature for testing. And the way that we usually do is based on the business value and the business risk. So for example, like the online banking application or mobile application that I know that everyone using that. So in my case, for example, I don't want anyone without my permission to log into my account and do stuff with my account, right? So to me, the authentication here is critical. And I believe that everyone has that feeling. And this is money application, right? So you want to use that to pay your bill. You want to use that to receive your salary, to do whatever with the money. So those features like payment, receive payment, view transaction summary, all of those are important. So those features need to go to the top priority list. So the feature like, I want to be able to change my residential address is important as well, but it's not critical as the one that I mentioned earlier. So we have the list of the feature with the priority, right? So focus on that. Focus on that list. So we can allocate resource better, and we don't become the bottleneck. So we support the process so that we have to balance the speed and quality in this case. So doing all of this, we eventually achieve 3 important goals of continuous testing. That is test early, test often, and test automatically. Think about this, the ultimate goal of this is to build the confidence in our software development at speed. Moving on to the good practice, we have some good practice here to share with everyone here. The first one is about automation. It's not about the test automation. It's about every repetitive task that you can automate. For example, environment setup. For example, data generation. For example, report generation, for example, right? So all of these tasks, you are doing that every single sprint, every time you need to deploy, to run that. So automate that, we save a lot of time. And you can plug that into the pipeline. So you don't have to do that manually. Speed up feedback loop. So this one I already mentioned, right? So the faster we give the feedback, the better. In automation, there are some mechanisms we can apply to give the feedback faster. The first one is fail fast. So for example, I have test case has 20 steps, and it's failed at step number 3. I don't have to run the rest. I fail the test case straight away. Because I don't want to spend time on those 17 steps because I know that someone needs to go here and look at the test case. So fail fast. So one test case doesn't matter, but if you think about the big number of test case and you apply fail fast, then you save a lot of time in the execution here. The other approach is we can run the test in parallel. So a lot of cloud platform nowadays you can use, especially in the UI scenario, where we want to run the set of number of feature on different browser or device. I'm sure that you're quite familiar with this. We can have the same test case running on those platforms in parallel quite easily with these platforms. But if you don't have the access to this, you can still do that using open source or different way. Non-functional tests. So this is also, I want to re-emphasize that by a story that I was with one of the big banks in Australia. We was doing the payment testing for the very big system. So we received requests coming from different banks, and we send the request to them as well. So a lot of interaction between different systems from external. We have very comprehensive unit test tools. We have very good functional automated, including API, UI. We have very good performance test tool. We put that all the CI, CD. And every time we want to run that, we just need to trigger that. So it looked really perfect, right? But eventually we got some production defect. And we asked ourselves the question, why did we miss these production defect? After we did the analysis, we reckoned that the production defect happened along the side with some other incident where our server will boot into the abnormal situation. So we end up creating another suite of tests that we call chaos testing. So we purposely boot the system into the extreme condition. It's not normal condition, it's extreme condition. And the way we did that where we have the load test run with the very high load. And then we go to the server and we restart the service and see how the application handle this. And we actually found a couple more defects from there. So what I want to say here is non-functional testing are really important because that will help us to prevent a loss of real-time, real-life defect, and it helps us prevent that from production. So don't forget non-functional testing. Put that into the CI pipeline if possible. It doesn't have to be 1,000 or million user. Could be a small number of user. But if you have the obvious problem in your code base, it will detect straight away. The next one is that we need to have the reliable test environment. So this is a very old topic, right? So test environment management is always challenging. And even if you have very good automated tools, you have very good setup in your test, but without the reliable environment, the result that's coming back from that cannot be trusted, right? And what can we do with the test result that we can't trust? There's no value from there. So we need to make sure that we handle the environment properly. Similar to test environment, the test data is also important. Right? So if we are in the project where we don't have the dependency of the test data, then we are lucky enough because we don't have to deal with the dependency here. We can just generate our test data using SQL, using any tool that we want. Then we can clean up after our test case, right? But then if we have the test data, that depend on the test data of another organization, for example. Or you have scenario where when you run your test, the test data that you use cannot be reused anymore. So that's one-time use test data. And in order to get that, you need to go through a lot of process, right? So those kind of scenario, we simply cannot control the test data. So that will create a lot of problem. So make sure that we have the proper data management strategy in our project, because that's very important. The last good practice that we usually apply is that we have very clear structure and clear metric defined for the CI. For example, it depends on the project, the technology. You can set like unit testing, you have to have 80%, 70%, it depends. But when you set that threshold, follow that. So creating new code, make sure that we have covered more than that. Otherwise, you are not going to go forward, right? Because it will be helpful for the quality point of view. Or if we want to deploy any build into any environment, then we need to have the certain pass rate of the regression. Because if we don't meet that target, there must be something wrong, either in environment, either in application, either in your test. Then we need to update that, right? So here are some quality gates that we normally use in our pipeline. So that's including the static code scanning. It's basically analyze the source code without executing that. So there's a lot of tools we can use to do this, to basically identify the problem potentially can happen. And that's the quick process. I will show you the process of doing that in the demo. And run through this process, it's just like 10 seconds. But it's really helpful to detect a problem. Unit testing, obviously, I think everyone knows this. And then we have the system testing. So I want to say this is the isolate system testing, where we treat the system isolate from the other external system so that we can focus solely on this system. This will help us to remove the dependency. And that's one of the things we can leverage for the CI. Because when we put this in the CI, we have that run independently. So, but if we have like the test that depend on all the system, so you cannot control that system, then it's very hard to put into the CI. Non-functional testing, yeah, I talk about that. Code review. So code review is still very important here, right? So that's the step where we automate a lot of this, but code review is where we actually involve human. We actually involve our peer into reviewing the code. Because we have a lot of check here, so when it goes to code review, it's more like most of the problem has been detected and fixed. The code review is the final stage to make sure that all the thing has been checked before we actually merge into any release branch or main branch. Then automatic regression. So after we merge into the main branch or release branch, we deploy to any environment, we always run the regression to make sure that we don't break anything. So in here, we actually run with the integrated environment. That means it will interact with all the system as well. So on the other side, you can see there's 3 areas that I separate there. The first one is pre-commit. Pre-commit will be happening in the local of the developer. So going to the next slide, I will talk more about that. The next one is the CI. This is where the code has been pushed into the repo. And after that, that's what happened where the code has been merged and deployed. So we have very clear, separate 3 stages of check here. And if you somehow slip from one of them, so the next one will catch the problem. So this is the example of the pre-commit check that we normally use. You see there, after developer hit commit, so add something into Git and then commit, then a lot of check will be there to make sure that we don't commit any bad code. So in this scenario, I'm showing you 3 checks. The first one, I explained that static code. The second one is unit testing and system testing. And then the third one is interesting. You can have this one or you can ignore this one, that's fine, but my recommendation is we need to have this check as well. I usually see developer or tester is writing the test automation commit message like fix something or clean up or fixing issue, which makes no sense if you look back 1 week later, right? So we usually enforce this commit message as well. It needs to follow the standard. Like, for example, if I'm working on user story 1, 2, 3, in my commit message, I need to have user story 1, 2, 3, and the detail of what I've done there. So if you look back after a while, you see the value of that. Because clearly, you can extract from that. In order to do user story 1, 2, 3, here is all the changes I actually made. This is the example of CI check, the second stage after pre-commit. That's where the code actually go into the repo. So a lot of things has been run here. You can see that it's including unit test, system test, load test, and chaos test here. So I tell the story about chaos, and I implement it as well here. Then feedback loop. So this one is just try to visualize the feedback loop. You can see that the developer doing something, doing the pre-commit check, and then it's go to the feature branch. You go into pull request for review, and then deploy. So you can see that if the issue were picked up from the feedback loop or pre-commit, that's much more faster. So if that's will pick up after deploy, so that's quite long, right? So the sooner we apply the quality gate, the better. All right, anti-pattern, what we should not do. This comes from our experience where in some project, we saw the testing really focus on end-to-end. And it's just end-to-end, nothing else, apart from a little bit of unit testing and then end-to-end. Understand that end-to-end testing is the simulation of the real-life use case, but then end-to-end testing usually is slow and is depend on a lot of different problems. So if we just ignore on off the test before that, focus on end-to-end testing only, if we found the defect, we don't know where the defect belongs to, right? So the debug, the troubleshooting process here is expensive. So focusing on this, we miss the opportunity to utilize the fast feedback from integration testing, lower level testing, right? So when we go through all of the low level testing, we go to the user end-to-end testing, the number of issues should be minimum because most of the problem has been detected in early stage. Overuse of UI test, here also another thing I saw from experience. This is because it's easier to understand from the UI point of view rather than looking at the API. But again, UI testing is very flaky. If you are working on test automation, you work on Playwright, Selenium, or some similar tool, flaky test is one of the problems that we need to handle properly. And also UI testing is very hard to maintain, and it takes time to develop as well. So again, if we think back about the dynamic testing triangle, right? So we see that integration testing, unit testing, the lower has bigger than the top one. Flaky test, ignoring flaky test. So this happens quite often. This create a very dangerous perception that when we see the test case fail, we immediately blame the environment. That's because of the environment timeout issue. So we tend to increase the chain for the defect to go to the higher environment. Because every morning we go to CI, we look at the result is just different. Because this test case passed yesterday, but failed the other day. Today is passed again. So don't ignore this. Go deep into the reason why. If that's flaky, isolate that. Try to find a way to fix that. If not because of the test, it's because of environment. Raise the problem with environment. This could be potential defect, right? Test dependency. So test dependency, that means you have one test case, but that depends on the result of the other test case. So for example, you have one test case create user, and you have another test case verify the detail of the user has been created. So what if the create user test case fail? So the second test case fail as well, right? So one of the good practice is that we want to create the test case that can be run independently, especially in automation. Hard coding test data, obviously, this is very, very clear that it's not something we want to do because it's hard to maintain. So one day we need to change the data. We need to go to every single place that we hard code. That's not flexible because if we want to switch to a different environment with different data, we cannot do that easily because it's hard coding, right? All right, so those are the anti-pattern of continuous testing. Enough with this slide. Let's go to the demo that we prepared. So in this scenario, don't worry about the diagram there, it's just the API for user to book the ticket, for example, or book the booking something. Could be ticket, could be hotel. There's two scenarios we want to demo today. The first scenario is someone has the proper setup with the pre-commit, with everything else. Then try to add some bad code into the code base and try to commit that. We want to show you that our pre-commit check can detect the problem, not fixing the problem. We need to fix that, but that will be detected. The second scenario could be someone missed the configuration or the configuration is not working properly. So the pre-commit check somehow couldn't detect the issue. So I have my colleague purposely disable the pre-commit check so that he can boost into the code base, and then we want the CI to be able to pick that up. Right. So let's go to the first. Let's stop sharing. The first scenario. Oh, sorry. Okay, cool. All right, can everyone see the screen? Yep. Yeah. So we have some good developer here. So when they look at this, they obviously see that this is very bad, right? You have password there. You have the query that potentially can be used by hacker to do the SQL injection. You have import datetime that you never use. Different thing here, right? I'm sure that a good developer now will never do that, but there will be a chain that we miss something from there. So let's say, I need to put it down. All right, so let's say, so is that too small? Can I just, yeah? Right, cool. I have one file that's a temporary demo bad code that's purposely created. Now I want to commit that. Okay. All good, all good?
Just duplicate the screen so you can see there.
Yeah, that's fine, all good,
yeah?
all good. Just random message. It will fail anyway from the previous step. So just run that. And I want to, oh yeah. You can see a lot of things actually running and perform the quality check there. And eventually they're saying that we have the problem. We have the problem here and we need to fix that. Then if I go up here, you can see, right? So this is the SQL that potentially can create the security problem. This also another try access. This is problem with the password that hacking into the code base. Also, let's see what else. All right, a lot of things here that need to be fixed. Right. So the idea of this is sometimes we're focusing on solving the problem, and sometimes we try to commit the code without really review that. People make mistakes, right? So we implement this so that when we do things, it will remind us there's something else we need to look at, right? So that's actually put the quality check in our work. From the very first day, commit the code. So with this bad code will never go to the repo. So that means we only allow the accepted quality code go in there. Now let's go through another demo on the second scenario. Let me go back here. This is the scenario where my colleague have to disable that check in local so that he can boost into the CI, see what CI can do. In CI is run more tests here. And you can see in this pull request, there's something wrong here. So I have the mini load test here where I just trigger 200 user in 60 seconds to just hit the API, 200 user in 60 seconds. See how it reacts. And I can see that nearly 2,000 requests fail. There's something wrong here. So stop. That's the first point. The second point is that you can see the whole bunch of commands that detect the problem that should have been detected in the pre-commit. So it will be done automatically. You can see that the hard coding password, the hard coding secrets is also a command here. This automatically review the pull request. All right. Going down, a lot of problem, similar problem like that. Then this is to demonstrate that we have different layers of quality check. If we miss one, the next layer will get that. And more importantly, we are doing this automatically. We don't have people to go there and look at that and do this manual check. So we are adding the value into the quality, but we are not stopping the speed of the team. So that's the key point. Now let's go back to the slide to see what else we can do. All right, so that is just the start of CI. What else we can do here? This is the age of AI, right? We use AI to generate the test case. We use AI to create the automated script. So leverage that instead of doing manual. Another thing we can do is intelligent test run, where, let's say, for example, we have 1,000 test case, and we just go to the code base, we update one functionality, just one method. We go in to run all of 1,000 test case again with that chain. We may do, right? But that will take time. So if we can build the mechanism to actually just do the analysis. So with the chain, what will be the impact? This function change, what will be the impact? We can even now do this without AI. We have the tool we can use to do this. But if we can apply AI, that could be another solution. I think it could be faster and more dynamic. Self-healing test. So that has been discussed in the previous talk, before this talk, right? So that you see how cool it is that nowadays the tool has been developed to automatically detect these. That's if you have that license for the software. But if you don't have, then we need to handle the proper way of doing automation, right? Have the great mechanism to handle these checks. Observability, though this is very important in the operation. We use this to get the log, get the event, get the data, then we can see the interstate of the system. We understand how healthy the system is, so that we can predict what could happen. The last one that's on top of my mind is predictive quality engineering. So if you haven't heard this one, that could be the great start to maybe Google that. But the idea of that is planning, doing testing, using the data. So we put a lot of data into the log, from the log, from the defect, from the commit message, commit code. So all the data you can gather. Put that into the machine learning model. And get out of that, the output of that is how can we prioritize our testing? What area we should focus on? So instead of like guessing what we should test, we use the data to predict. So that's called predict quality engineering. And that's conclude the talk. I understand that I can have the question, right? All right. There is the gift card, $50 that I can give to someone who can answer the question. You ready? All right. How can we prioritize the test? I see the one at the end, please. And? Yes, man. Thank you. Here you go. I give it to you.